All right, guys, you got your quiz tomorrow. It's going to be as hard as you want to make it. Okay, it will be as hard as you want to make this. Here you go on your screen. That's what I'm going to give you. That'll be on the top of your test tomorrow, whether you're taking it on formative or here in class. I'm going to give you those four. You don't need to memorize them. And I'm also going to let you have access to two tabs. One tab will be your Desmos rectangular grid. The second tab will be your Desmos polar grid. All right, so I'm giving you access to everything. I don't know what, other than the actual answers, I don't know what else I should be giving you here. All right, I'm not going to screw you over. I'm going to tell you exactly today as we review what to expect. And by tomorrow, it's game day. Do you know how to do it or not? Are you prepared or not to do this? All right, fail to prepare, prepare to fail. One of my favorite quotes. So let's go. Let's start day 14. I am not going to go over all of these. We don't have time, and you guys don't have the patience either. All right, so I'm going to go over probably one or two from each section now. First thing you need to have the ability to do. There's three things you need to have the ability to do tomorrow. Thing to do number one, I'll give you a rectangular. What is it in polar? All right. Now remember, your answer tomorrow when I ask for a polar coordinate has to come in the form of an R value that's always positive and an angle that's positive and in radians. All right. So that's what I'm looking for tomorrow. Your final answer, your final coordinate should have an R value that's positive and an angle that's in radians that's also positive. So let's figure out how I get both right now by doing question number one. -4, 4. Throw it on a quick graph. You got to know what quadrant it's in. Go. Throw it on a quick graph right now. -4, 4. I don't care the preciseness, the exactness. You just got to know where the heck it is. So -4, 4. Hopefully you're putting it somewhere in the second quadrant. Then you're going to draw a line from the origin to that point. There you go. Whatever that equals, that's your R value. That's your R value right there, from your point to the origin. That's your R value. Finish this diagram by drawing a vertical line down. So it forms a right triangle. Draw your vertical line down. Now you have a right triangle. That's pretty crappy by me. Step up your game. There we go. Now you have a right triangle. Always draw a vertical line, no matter what quadrant you're in. Draw a vertical line. You should already know two side lengths. Use your coordinate to find two side lengths. -4 and 4. Put them on your triangle. -4 is your x-axis. +4 is your y-axis. Okay, you already know two side lengths just by giving the coordinate. Now, how are we going to figure out the R value? What have we been doing? Or what can you do? Pythag. There you go. Done. So here we go. Pythag to find the R. 4 squared plus -4 squared equals R squared. Pythagorean Theorem. When you square, the numbers come out to be positive. Sorry I have to yell that, but that gets me fired up. Anytime you square something, it comes positive. 16 plus 16, positive 16, equals R squared. 16 and 16, 32, equals R squared. How do you get R by itself now? Do what on both sides? Square root both sides. And I am really trying to make this as easy as possible tomorrow. I'm not even going to ask you to break down 32. Just leave it radical 32. I'm not going to be like, all right, guys, let's find a perfect square that goes into 32. Let's break it down. No, I'm not even going to do that to you. So please have a little respect going back and forth between me and you to prepare yourself. All right, there's a lot of little things I could be doing to make this difficult tomorrow. One of them is not breaking down a radical. So leave it square root of 32. All right, there's your R value. Let's talk theta now. Let's talk theta. All right, first thing. What quadrant am I in?
3.
Oh, boy.
2.
2. So your answer better be between 90 and what? 180. You're in quadrant 2. So your answer better be in between 90 and 180. How do I get that angle? Let's go. I'm going to use tangent. So to find theta, I'm going to always use tangent. And remember, we're going to be doing inverse, so the -1 button on the calculator. We're always going to go second tangent. Opposite side over adjacent side. Opposite over adjacent. Here we go. And remember, this is the angle we're finding right there, the reference angle we're finding. So opposite is 4, adjacent -4. I will share with you, one of my period 2 students said, Mr. Carlino, can we, instead of doing it opposite over adjacent, can we remember just y over x instead? And that's fine too. Whatever floats your boat, because it's always the y coordinate over the x, y over x. It's up to you. I don't care. Opposite over adjacent, y over x. All right, everyone go to their calculator now. Make sure you're in degree mode. Make sure you're in degree mode. Am I in degree mode? Yep. Second tangent. -4. So what was it? +4? 4, sorry. +4 over -4. Okay, it comes out to be -45, but remember, we always got to have positive degree measures. So just take the negative away and put 45. All right, so my angle is 45 degrees. If you leave it like that, I'm going to put you in a headlock. You just told me we're in quadrant 2. You cannot have an angle of 45 in quadrant 2. So knowing that angle's 45, what should I do to put it in quadrant 2?
You subtract 45 from 180.
Thank you, Caroline. I'm going to take 180 minus 45 to get it into quadrant 2. So my angle, 135 degrees. But I am not going to loosen up on that headlock just yet. We just described your final answer in polar has to be in radians. In radians. So I take 135. What do I multiply by to get it into radians? Whew.
Pi over 180.
Pi over 180. I'm going to leave the pi in my answer and just go simply to my calculator and do 135 over 180 and see what the reduced fraction is. So I'll go back to my calculator, get a fraction template, and say, hey, 135 over 180, can you please reduce that for me? Thank you. 3 over 4. So my angle, 3 pi over 4. Put the two together now. Put the two together. There'll be a spot for you to write your answer tomorrow. My polar point, r, radical 32, comma, theta, 3 pi over 4. There's your polar point. A lot of work, I know, but it's the same steps every time. Only step that might be different is if it's in a different quadrant than 2. Anything I can answer from you right now, putting that rectangular into polar. Before I move on, what would happen if it's in a different quadrant? Let me go over the rules if it's in a different quadrant. So quadrant 2, the one we're in, we do 180 minus the angle we find on the calculator. Anybody remember, what if it's in quadrant 3? What do I need to do with the angle in my calculator?
Don't you add it?
Add it to 180. There you go. 180 plus the angle. in my calculator. And then finally, what if I'm in quad 4?
Subtract 360.
360 minus the angle. That's how I get my theta in all those. Ooh, what if it's in quad 1?
Leave it.
Leave it. Yep, that is your angle. Anything I can answer for you guys there? So there'll be a couple like that. I think maybe a multiple choice and maybe one you have to do out like this. All right, can you go to number 4, please? Number 4. Sometimes you don't have to do all that work. It's not needed. Sometimes you don't have to do it. What happens if actually your point's on the axes now? You should not have to do all that work. All right, go ahead, draw yourself a quick sketch. Let me see where 0, -5 is for you. Where's 0, -5? Some of you guys need, not putting the pressure on, but some of you guys need to do well here on this one because your first polar quiz was an abomination, as you can see by your Aspen grade. 3 passing quarters does not equal passing for the year, unfortunately, if you know how averages work. All right, hopefully you're putting 0, -5 right down here. Somewhere on this y-axis, 0, -5. Guys, you shouldn't have to do a darn thing here. Maybe a little something here, but... All right, let's talk polar point. There's no reason to do Pythag. And some of you guys made this mistake on your assignment. R value is not 0. If the R value is 0, that means it didn't move. It's right in the middle, which is not. The R value is how far it is from the middle. How far is this point from the middle?
5.
5, positive 5 units. It's not 0. 0 would be right at the middle, which it's not. It's 5 units away. All right, let's talk about the angle. In degrees, where is it? What's this angle here in degrees? Don't actually, you know what? I got to do a better job here today. I'm already failing. I got to start calling on you guys. Here we go. What's that angle in degrees? Wake it up at home. Hunter, what's that angle in degrees right there?
Oh, it's 270.
Thank you. 270 degrees. Not what I want in your answer, though, because it's got to be in radians. So either you know it off the top of your head and write it in. If you don't know off the top of your head, what do you have to multiply by? 270 times what to get it into radians? Nick, what do you got? Pi over 180. So if you don't know off the top of your head what 270 is in radians, multiply it by pi over 180, and that'll get you the answer. So I'll give you a second, and I'm going to ask another person, what is it in radians? Liz, what is 270 in radians?
One second.
Yep, take your time whenever you're ready. 270 in radians, that's what I'm looking for.
Pi over 2.
There you go. So that's what I want in your final answer, everybody. Thank you, Liz. 3 pi over 2. All right? So if it's on the line, if it's on one of the axes, you should not be doing Pythag or tangent at all. All right? Okay. Turning a point into polar. We're done. I'm done reviewing that. You'll do some more on your own in a minute. Any issues there? Questions? All right. Now what we have to work on is changing the equations from one form to the other. All right, changing these equations from one form to the other. So I'm just gonna do number 7. All right, I think that's a good one to do with you. Number 7, changing it into polar, which means at the end of this answer, I need R equals something. All right, if I'm gonna leave it in polar, I need R equals something. So this is where all your substitutions will come in. And again, up on your screen, I'm going to give you these formulas tomorrow for you. Don't memorize them. I'm going to give them to you. All right, so we got an X and a Y I can plug in for. Let's start. What do you want to plug in for X? What have we been plugging in for X all along in this unit? What do I got up there? 5 spot. Let's go, Ella. What do you want to plug in for X?
R cosine theta.
Okay, all squared now, everybody. R cosine theta. I'm going to square it all. That's what Ella just plugged in for X. Plus, I think we have a substitution for Y as well. Yes, we do. Isaiah, what's my substitution for Y?
R sine theta.
R sine theta. All squared, again, that's what I just plugged in for Y, equals 100. All right, now we got to do the algebra part. We did the substitution, now we got to do all the algebra to get R by itself. When I square the whole parenthesis, everything inside gets squared. R squared and cosine gets squared. Next parenthesis, same thing. R gets squared, sine gets squared. 100 just chilling out there on its own. There's the 100. All right, do we remember how to get those R squareds into one R there? What's my next move here? They both have R squared in them. What do you think here? Next move? Caroline, next move?
Factor them out.
Yep, factor out an R squared. So help me out, Caroline. I'm going to take an R squared out. What's left in both now?
Cosine.
Just cosine or cosine squared?
Cosine squared.
Good, yep.
Theta plus sine squared theta.
Good.
Equals 100.
I factor out an R squared. Sometimes I may just factor out an R, but they both had R squared, so I'll factor it out. All right, look what's inside the parentheses. It should look familiar from what I'm going to give you. Okay, it looks familiar. One of the formulas, cosine squared plus sine squared, also known as, what can I substitute in for there? Will, what can I substitute in for cosine squared plus sine squared? Here you go. Here's the formulas you'll be given. Cosine squared plus sine squared, the same as what?
1.
There you go. So that's a 1 in there, essentially just wiping it out. Let's be honest, right? It just wipes it out. R squared times 1 is just R squared. And then from here, still not good enough for me, because remember, it's got to be R by itself. That's not good enough. Got to be R by itself. What do you want, Mason? Last step on both sides?
We have to, what's the opposite of square root? I blanked on what it's called, but we got to do it R equals 10.
Okay, square. You were right, square root. So R equals 10. What's up, Nick?
Can you just plug in R squared for X squared plus Y squared at the beginning? And you get R squared equals 100.
You could, yeah, you got me there. Good job. Got me there, you son of a gun. Good. Yes, Nick, if anybody didn't hear that, Nick one-upped me in class here and said at the beginning, he saw, hey, I got X squared plus Y squared. Isn't that the same as R squared based on my formulas? And yeah, he's right. So I could have just substituted in R squared, got it equal to 100, R equals 10. Yep. Thanks, Nick. Now, tomorrow, will you please take advantage of it? Honestly, when you sign off, what else you got going on in your life when you sign off tomorrow? Honestly. Can you please go to Desmos, plug in X squared plus Y squared equals 100, and in the other graph, plug in r equals 10 and make sure they're both the same. All right, take that. What's it probably going to take? What do you think? 45 seconds?
A minute.
To type, maybe a minute tops
Yeah.
if you're a slow typer, to check both. And I will, before we get to our last problem, I will let you know there's going to be some multiple choices tomorrow that say which polar equation matches the following rectangular one. Can you just, I don't want to, it's not cheating. Can you just plug both into Desmos and see which ones match? All right, instead of trying to make your life a headache and try to substitute in this and substitute in that, just type your original into Desmos and all the multiple choices and see which one match. All right? All right, last thing, going backwards. This is the toughest one, I think. If I give you polar and you got to give me x's and y's back. So here you go. Let's go to number 12. Let's go to number 12. R equals 3 cosine theta. Turn it into rectangular, so x's and y's only. Remember the three things you're trying to make it look like. You're trying to get an r squared maybe going. You're trying to get an r cosine theta going. Or maybe, can you get an r sine theta going? All right, you're looking for one of those three to get going. I know what most of you are going to do, and I want you to try it first. Does it make sense squaring both sides? Because I'll get r squared. Does it make sense squaring both sides?
Are we on 11?
No, we're on 12.
Okay, then no, it doesn't.
No, it does not, right? Because, yeah, it'll give me r squared on the left, but then it's going to give me a lot of crud on the right. I have no idea what the deal is there. It's not going to give me anything to substitute in. So now I say to myself, is there another way I could get r squared other than squaring it? And that is what you guys are, somebody's going to decide for me. How else could I get an r squared other than squaring it? Because we just said that didn't work. Bassett, what do you got? How else can I get r squared other than squaring it?
Multiply each side by.
Good job. Multiply both sides by r. So I'll get r squared on this side, and then I'll get something nice on the other side as well. 3 r cosine theta. Sometimes squaring would work. Sometimes it doesn't. So I need to multiply both sides by r. All right, now it's on to you guys. Can you substitute in for me? 13. Eliana, here we go. What can I substitute in for r squared?
For r squared, you can do x squared plus y squared.
Okay, x squared plus y squared. And then over here, I'll keep the 3. And what do you want to substitute in for r cosine theta?
Then you can do x.
Done. There you go. I can substitute in x. So x in for r cosine theta, x squared plus y squared in for r squared. Make sure your final answer just has x's and y's only, which it does. And take that 45 seconds to a minute to check both graphs on Desmos. While you're here, guys, can you please cross off number 11? I am not going to give you any secants or cosecants tomorrow. You're welcome. All right, so no secants or cosecants tomorrow. All right, nobody is signing off early. What you're going to do instead, everyone's going to go to classroom right now. I'm sure you got the tab open. Everyone's going to go to classroom. Look under Unit 8 for me. Mine's just a little slower. All right, under Unit 8, you should have review for quiz number 2 answers. There it is. Open it up. And you guys have 15 minutes right now to start practicing the other questions we did not hit on. Please check your answers and all my work. All right, I seriously took a while on this to make it detailed. So please check all your work. All right, make sure it all matches. Let me know if you have any questions over the next 15 minutes. Am I going to know if you're practicing or not at home? Absolutely not. But you guys can do the your overall average by taking the first 3 quarters and adding in whatever you got for fourth quarter now and dividing by 4 and see if you're going to pass or not. Because some of you guys need a little boost here tomorrow. Here we go. Get going. Reach out to me, please. Reach out to me if you got questions.